Welcome. Thanks so much for joining. I'm Dr. Pamela Peele. I'm the Chief Analytics Officer at UPMC on the Insurance Services Division and at UPMC Enterprises, which is our venture capital and startup arm of UPMC. Thanks for spending some time, which will be a short session today. I want to talk to you about something very important as you go about your modeling work under this data challenge. Most of us, when we model, try to make our models as well-performing as we can possibly make them. What do I mean by that? So you're modeling something to predict. You want your prediction to be as accurate as it can be. That's a well-performing model. There are various ways to look at the performance of your model. Sensitivity and specificity are two very common ways to do that. Predicted positive rates are other ways. You can Google all of that. We don't need a whiteboard, and I'm not going to show you the math. It's not hard. The point is, sensitivity, which is a measure, tells you what percentage of the true positives do you actually capture with your model. So a model that has a sensitivity of 0.8 captures 80% of the true positives. That means they capture some false positives too. That's what the other 20% represent. So when you're modeling, what are you trying to do and what are you going to use your model for should drive whether you're maximizing sensitivity, the number of true positives that you capture, or specificity, the number of false positives you don't pick up. When you're modeling something for an intervention, like you might be making a model to identify who is likely to be homeless or who is likely to be receptive to taking a particular intervention. To the extent that these interventions or what you're doing with your model cost money, like a person goes out to the house and does something, or a person goes and finds somebody, you want to make sure that you are using your model to maximize the intervention. The default for most people when they model is to try to maximize the sensitivity. I want to find as many true positives as I can possibly find. When you are modeling for an intervention and the intervention is expensive, you want to maximize your specificity. That is, you want to make sure that you're not falsely identifying people. You want as few false positives as possible because you're applying an expensive intervention to them. That means that you'll miss some true positives because your model will be trained to make sure that the negatives are negative. So then it's a trade-off between sensitivity and specificity. But again, in math, we generally tend to want to maximize the number of true positives that we are identifying. In business, particularly business with expensive interventions, we want to make sure that we don't have false positives because false positives are diverting our resources to somebody who doesn't need it. So that's the key on sensitivity and specificity. Just Google it. It's a very straightforward. You had it in statistics, I'm sure. The point isn't how do you calculate them. The point is which one are you trying to train your model to perform the best with. And specificity, when you have an expensive intervention, is the way to train your model so that it fills your business need. Thanks for listening in. Thanks for being here. Best of luck in your challenge. I know you all do great. And I will be seeing you at judging time.